Beneath our feet, locked within rock layers dating back 65 million years, scientists have uncovered something that defies all logic. Microscopic spheres of rare metals scattered across the globe. Their distribution eerily mirrors the fallout patterns from modern nuclear tests. Except these traces were left long before humans ever existed. For as long as we've studied history, we've believed we were the first to split the atom, forge metals, burn fossil fuels, and alter the very air we breathe. But what if that belief is wrong? What if Earth has been home to other advanced civilizations, ones so ancient that time itself has erased all visible traces? Today, we explore the evidence that could upend our entire understanding of this planet's past. We'll sift through vanished nuclear signatures, examine mysterious mass extinctions, and confront the vast silent gaps in the fossil record. Our story begins in 1980. Geologist Walter Alvarez, studying rock layers in Italy, stumbled upon something extraordinary, a thin clay band marking the boundary between the Cretaceous and Paleogene periods. Inside it was an astonishing concentration of iridium, a rare metal common in asteroids but almost absent in Earth's crust. This single discovery transformed science's view of mass extinction. That iridium layer became the smoking gun for the asteroid impact that wiped out the dinosaurs 65 million years ago. But it also raised a haunting question. If a single catastrophic day can leave such a clear signature after tens of millions of years, what sort of marks might an advanced civilization leave behind? And would we even know how to recognize them? From this thought came the Silurian Hypothesis, named, oddly enough, after an alien species from Doctor Who. It asks whether industrial civilizations might have existed on Earth long before humans, their evidence altered beyond recognition by deep time. To grasp this idea, consider the scale. If human industry lasts 10,000 years, it would represent just 0.002% of Earth's 4.5 billion year history. Detecting such a sliver of time would be like finding a single page in a library of 4 million books, yet the traces should be there. Every industrial civilization would leave behind chemical fingerprints, altered atmospheres, stubborn waste products, isotopes that endure far longer than metal or stone. Our impact is obvious. We're flooding the skies with carbon dioxide, scattering plastics across every continent, and producing radioactive isotopes that will linger for millennia. Future geologists will have no trouble spotting our presence. But what if earlier civilizations used technologies we've never seen? What if their materials decayed differently from our plastics, or their energy sources left subtler scars? Their traces could be hiding in plain sight, written in rock and sediment, dismissed as natural events. The iridium layer proves one thing beyond doubt. Earth remembers. It keeps records of cataclysms across unimaginable spans of time. If the aftermath of a single asteroid strike is still visible after 65 million years, then so too could be the shadows of civilizations that endured for thousands, and so scientists began re-examining the geological record, looking for strange patterns, signs that could point to an ancient technological age. What they found challenged our most basic assumptions about life's story. The fossil record should read like a complete biography of Earth's creatures. Instead, it's more like a book with entire chapters torn out, only scattered fragments remain. Paleontologists call them gaps, but the word barely conveys the scale of what's missing. Take the Cambrian explosion, 540 million years ago, a moment when complex life suddenly bursts into existence. One layer shows mostly simple microbes. The next, an ocean full of creatures with eyes, shells, and intricate body designs. This leap should have taken millions of years of gradual change, yet in geological terms, it happened almost instantly. The Cambrian explosion is just one example. Throughout history, life seems to leap forward in strange, unexplained bursts. Entire species appear fully formed, thrive for a time, then vanish without any clear reason. Conventional science blames preservation bias, the idea that soft-bodied organisms fossilize poorly, leaving gaps where intermediate forms once lived. Environmental conditions, too, play a role in what survives in stone. These factors undoubtedly matter, but they may not be the whole story. But some gaps in Earth's history seem too precise, too well-timed to be explained away as random quirks of fossil preservation. Again and again, they line up with massive shifts in atmospheric composition, ocean chemistry, and climate, as if something or someone was deliberately altering the planet. Take the Great Oxygenation Event, 2 billion years ago. Practically overnight, oxygen levels in the air surged, wiping out most existing life, while paving the way for entirely new organisms to emerge. Textbooks attribute it to cyanobacteria discovering photosynthesis, but the scale and timing are suspiciously sharp for a purely natural event. The oxygen spike follows the kind of pattern you might expect if a civilization intentionally re-engineered the atmosphere. This rhythm repeats through the fossil record. Long stability broken by sudden upheaval, mass extinctions followed by an explosion of new species, chemical fingerprints that point to massive, coordinated changes in planetary systems. Yes, These could be rare natural events triggered by Earth's own feedback loops, but they could also be the handiwork of intelligent life. If earlier civilizations burned through vast resources, polluted skies, and reshaped oceans, their activity might have killed off most life, creating those mysterious gaps in the record. The rapid rise of new species could be the planet healing, or the result of deliberate genetic engineering. And the rocks tell even stranger stories. Every smokestack, every blast furnace, every heavy machine leaves chemical traces that survive long after steel and stone have crumbled. These markers become part of the geological record, preserved for millions of years. Modern industry creates unique isotope ratios that nature doesn't replicate. Burn fossil fuels, and you release ancient carbon with a distinctive signature, one that settles into ice cores, sediments, and tree rings. Test nuclear weapons, and you create isotopes that simply don't occur naturally. Markers so obvious that future scientists will instantly recognize them. But here's the twist. Scientists have found isotope anomalies that predate humanity by millions of years, at the boundary marking the Great Dying, Earth's worst extinction event 252 million years ago. Carbon isotope ratios appear that match the results of burning every last drop of coal, oil, and gas on the planet. Mainstream science blames massive volcanic eruptions or methane releases, but the chemical signature is eerily similar to industrial-scale combustion. Ice core records, stretching back 800,000 years, reveal abrupt greenhouse gas spikes, sudden rises in CO2 and methane that linger for thousands of years before fading. The patterns look almost identical to modern industrial activity and occur repeatedly, each time preceded by subtle shifts in atmospheric chemistry that suggest deliberate intervention. In Colorado, rock layers contain microscopic titanium spheres, particles only formed in extremely high-temperature industrial processes, yet these strata formed millions of years before metallurgy existed. Ocean sediments from the deepest basins hold similar metallic anomalies, spread globally as if released from countless sources across different continents. Then comes perhaps the most unsettling find: synthetic materials where none should exist. Plastics, for instance, are humanity's most enduring geological gift. Long after our bones turn to dust, plastic fragments will remain buried in sediments, marking the Anthropocene with an unmistakable layer. Yet deep-sea cores and remote sediments have turned up microscopic polymer particles in strata millions of years old. They share the same resistance to decay as modern plastics, but with molecular structures better than ours, engineered for even greater durability. Some of these ancient polymers were found perfectly preserved in Antarctic ice hundreds of thousands of years old, their chemical makeup still intact. If these aren't the result of some unknown natural process, they point to civilized audience that mastered material science far beyond our own. The nuclear evidence is no less shocking. In 1972, scientists studying uranium deposits at Oklo in Gabon discovered signs of sustained nuclear chain reactions, natural reactors that ran for hundreds of thousands of years, 2 billion years ago. But our own proved nuclear activity can be preserved in rock for billions of years. But other uranium deposits in Kazakhstan, for example, show isotope ratios identical to modern nuclear weapons tests in rock layers 50 million years old. Similar anomalies have been found on 6 continents, suggesting global-scale nuclear testing long before humans existed. So ice cores even contain isotopes that can either be created in advanced reactors or particle accelerators, and these layers coincide with periods of mass extinction. The deeper scientists dig, the clearer the pattern becomes. Multiple episodes of technological rise, global-scale industry, environmental manipulation, and then total disappearance. If these readings are real, then humanity might just be the latest chapter in a very old, very fragile cycle. Soil chemistry reveals stark shifts in rainfall patterns and temperature swings. Shifts that line up almost perfectly with the greenhouse gas anomalies found in ancient ice cores. These weren't random changes. They seem to match periods when someone, long ago, was actively shaping the climate. In fact, geological records suggest that Earth's climate often stayed unnaturally stable, even when natural forces should have sent it into deep freezes or sweltering heat waves. It's as if advanced engineers were holding the planet in a sweet spot, perfect for large populations and technological growth. Whoever they were, they appear to have understood Earth's climate systems even better than we do now. They managed atmospheric chemistry on a global scale, keeping conditions stable through multiple natural climate swings that should have been catastrophic. But some of the most fascinating clues point to something even bigger: the possibility that ancient civilizations once attempted the ultimate engineering feat, reshaping the very air we breathe. Earth's atmosphere is a living archive. Every volcanic eruption, asteroid strike, burst of photosynthesis, or rise of new life has left its signature in the chemistry of our air, preserved in ice, locked in rocks, and hidden in ocean depths. This record is so precise that scientists can identify specific volcanic events from thousands of years ago, trace the spread of ancient wildfires, and pinpoint the moment oxygen began filling our skies. If anyone had manipulated the atmosphere on a large scale, the evidence should still be there, and it is. Recent analysis of ancient air samples shows changes so extensive, so carefully engineered, they push the limits of what we thought possible. Air bubbles trapped in amber from 100 million years ago contain oxygen levels about 35% higher than today, but the isotope patterns point to artificial enrichment, not natural biology. To achieve this, someone would have had to strip massive amounts of carbon dioxide from the air and boost oxygen far beyond what plants could produce. This was climate control on a scale far beyond anything humans have ever attempted. Deep ice cores from both poles tell a similar story, entire atmospheric makeovers, not just tweaks to greenhouse gases. Evaporation, the more ingredient of air, shows isotope ratios suggesting it was deliberately altered. Such manipulation could have boosted combustion, improved industrial processes, and slowed metal corrosion, effectively engineering the air itself for an advanced machine-driven civilization. Ocean sediments reveal an even more astonishing twist, traces of synthetic gases with no natural origin anywhere in our solar system. Some appear designed to trap heat during cold periods, others to shield life from dangerous cosmic rays. Those were multi-purpose atmospheric upgrades, coordinated on a planetary scale, using knowledge we still don't have today. But not all attempts succeeded. Some layers show rapid changes followed by quick reversals, hinting at trial-and-error experiments that went wrong. The shocking finds are gases from 200 million years ago, tailored for life forms that no longer exist, gases that would be toxic to us, but ideal for completely different biochemistry. It suggests Earth may have hosted entirely different biospheres in the past, each engineered by its rolling civilization, and the atmosphere is only the beginning. The geological record of mass extinctions, the 5 great die-offs in Earth's history, carries signs that some may not have been accidents of nature at all. Take the Permian-Triassic extinction, the so-called Great Dying, 252 million years ago, when 96% of marine species and 70% of land animals vanished. The osses were oddly selective. Some species that should have perished survived, while others that seemed perfectly adapted were wiped out. This doesn't look like random disaster, it looks like targeting. Chemical residues from that era contain synthetic toxins iron in nature, designed to disrupt specific biological systems while leaving others untouched. The distribution was global, uniform, the kind of precision no actual process could achieve. And ocean cores from that period. Scientists have found microscopic remains of artificially engineered microorganisms, hinting at biological weapons deployed on a planetary scale. Other extinction events, like the Ordovician Silurian die-off, show similar patterns. Targeted elimination followed almost instantly by the appearance of no species already perfectly adapted to the new environment. This is far too fast for natural evolution, suggesting those extinctions may have been planned resets. Solar boundaries even contain isotope signatures consistent with nuclear weapons, on a scale far beyond anything humans have ever unleashed. Others bear traces of space-based strikes, high-energy impacts in the upper atmosphere, or possibly even asteroid redirection. In the case of the dinosaur-killing impact 66 million years ago, some isotope data suggests the asteroid's path may have been guided. And always Antarctica, a frozen vault holding millions of years of perfectly preserved planetary history. With 2 miles of ice lie gases from warm periods when the continent was lush and green, gases laced with signs of massive industrial activity. Ground-penetrating radar has revealed vast artificial structures under the ice, laid out in geometric patterns stretching for hundreds of miles. Bulk-for materials unknown in nature, organic remains found deep below contain DNA sequences that appear to be artificially inserted, life forms genetically engineered for extreme cold, lower light, and industrial purposes. Minerals beneath the ice are arranged in patterns suggesting vast mining operations. Sediment layers even contain microscopic machine parts made with nanotechnology we still can't match. Some of these buried structures resemble aerospace launch sites, perfectly placed for polar orbital access when Antarctica was ice-free. Others seem to be enormous geothermal power plants, feed on a unified energy grid that spanned the entire continent, a grid producing far more power than humanity generates today. Evidence even suggests that the ice sheet itself may have been engineered, a deliberate planetary cloning project, perhaps as a time capsule for future discoverers. And the deeper we dig in ice, rock, and ocean beds, the clearer it becomes. Earth's history holds unmistakable techno-signatures, pollution patterns, isotope ratios, megascale construction, and artifacts far older than humanity itself. Civilizations have risen and fallen here long before us, each one shaping the planet, each leaving behind array fragments for the next to find.